Hello everyone, and glad you made it back to the PrimateCast. I'm your host, Andrew McIntosh, and with me in the studio is summer intern Sophie Bernstein.
Hi everybody.
Today is July 31st, 2014, on the day of recording, and we're coming back with the second installment of our podcast series from the Japan Society for Animal Psychology Annual Congress, which occurred from July 19th to the 21st of this year.
And in this installment, we're going to be looking at non-human animal models of prosociality, in other words, helping others.
So the first special symposium that occurred at this Congress was about higher behavioral functions in animals, called Their Mind and Evolution. But basically what this symposium was focusing on was empathic systems. So the idea of prosociality in animal behavior. And the first speaker we're going to hear from is Dr. Ayaka Takimoto.
Ayaka is a Japan Society for the Promotion of Science postdoctoral fellow at the University of Tokyo. She works on investigating the underlying mechanisms that drive prosocial behavior, specifically in tufted capuchins.
Right, and so in this interview, we will be talking mainly about her tufted capuchin work, but actually she's kind of approached this subject a little bit more broadly, has done work with horses as well. So when she starts to talk about the mechanisms that she's proposing for maintaining this type of behavior, it's coming from kind of a wider view than just this monkey work. So we started by asking Ayaka to tell us about her overarching goals.
I want to reveal the evolutionary process of prosocial behavior by exploring factors, social factors or ecological factors that influence our prosocial behavior.
Before we dive into what the specifics are of Ayaka's research, we asked her to define what prosociality is.
My definition is the most general one. This is the actions to benefit or help others.
So the ideas of prosocial behavior, prosociality, and empathy in animals are obviously linked. And so for anyone who's interested, you can check back to a previous podcast we did with Dr. Franz de Waal, where he's one of the pioneers of empathy in animals and gave us a good interview. So you can find out more information about that. But in that lab, at Franz's lab at Yerkes, they do a lot of work with chimpanzees and capuchins and testing their capacities for prosocial behaviors, prosocial choices.
So then we went on to ask Ayaka what she does and how to test prosociality in tufted capuchins at the University of Tokyo lab.
It's best to test many primates or non-primate animals by the same procedure, but it's also difficult to apply the same procedure to compare each species fairly, because depending upon the species, the appropriate method is different. So I'm thinking what method is best for my theme.
Then Ayaka went on to tell us what points we needed to look at in order to understand if the actor's choices were prosocial or not.
Prosocial choice task is to test whether the actor benefits others. The important point is comparison between actor's choices in the alone condition and recipient present condition. Then the actor has two options. One is prosocial one and the other one is selfish one. The actor can get the same reward regardless of its choices, but the recipient get high value reward or low value reward. If the recipient was absent, the actor's choices will be random because the actor can get the same reward regardless of its choice. But if the recipient was present, then if the actor has prosociality, actors should choose prosocial option more often than selfish option. So if the actor have prosociality, the actor should choose the prosocial option in the first condition when the recipient was present than when the recipient absent.
Ayaka found that the monkeys did tend to make prosocial choices. However, the relationships between individuals tended to have an effect, and she didn't exactly find everything she was expecting.
In my studies, the tufted capuchin monkeys behave prosocially only for the subordinate recipient. But when the recipient contributes to the labor, that is required to get a reward, tufted capuchin monkeys behave prosocially for the both recipient, regardless of the social rank of the recipient.
So it's really neat always to see these animals continually coming up with these pro-social choices and actually helping each other. And it's actually not so hard to think about why that would be beneficial, even in a wild setting in social animals, to help others and obviously to be helped by others. But a lot of Ayaka's research is also about finding out what maintains those choices, even in the short term. So what are the underlying mechanisms?
One of these underlying mechanisms Ayaka talks about is inequity aversion, which can also be summarized as a sense of fairness.
Advantageous inequity aversion is a negative response to an inequitable outcome in which an individual earns more than another individual. That is a feeling of guilt. On the other hand, disadvantageous inequity aversion is a negative response to an inequitable outcome in which an individual earns less than another individual. That is a feeling of envy.
When thinking about these prosocial behaviors, a word that may come to mind is empathy. So we asked Ayaka to define this term and let us know how this fits into the framework of her study.
By Duval, empathy's definition is the capacity to be affected by and share the emotional state of another, assess the reasons for the other's state, and or identify with the other and adopt his or her perspective. But the definition is very different, so this may be correct, but depending upon the research area or researchers.
Okay, so just to take a bit of a break here for a second, for the listeners to maybe solidify an understanding of what this inequity aversion actually looks like. If you go to YouTube, you can actually find video clips with millions of hits already of work that has come out of Frans de Waal's lab at Yerkes, showing capuchins actually engaging in this kind of, or interpreted as capuchins engaging in this kind of inequity aversion, where if an individual next to them is offered a grape and they're only offered a cucumber, they have kind of quite a strong reaction to it. And so the videos really hit that point home. But going back to Ayaka's work, she also has put together this quite a nice metaphor, I think, to help explain this idea of how inequity aversion maintains pro-social behavior.
Yeah, she has this excellent graphic that she used in her talk of a car that shows the driving components, how the wheels fit into the brake system, and how these pro-social choices are kind of driven.
And so here's Ayaka telling us about that.
Empathy promotes but does not stabilize pro-social behavior. However, a sense of fairness stabilizes it but does not promote it. So these two psychological mechanisms can be viewed like a car's accelerator and brake. To drive a car, pro-sociality, both an accelerator, empathy, and a brake, a sense of fairness, are necessary. Here, a sense of fairness means DI. And balance between the two is important. A brake, of course, cannot start a car, and an accelerator cannot stop a car from crashing. So both fairness and empathy are essential for pro-social behavior.
Okay, so that was Dr. Ayaka Takimoto talking about pro-social behavior in primates, where it might not be such a surprising thing to imagine why those kinds of behaviors, even helping behaviors, would evolve in primates, which are highly social animals. But actually, there are various accounts coming up from researchers around the world where a number of species might engage in similar behavior.
For example, we have Dr. Peggy Mason from the University of Chicago telling us about helping behaviors in rats.
What we're interested in is trying to see whether rodents are type of mammal, but not a fancy mammal, not like a non-human primate. And we were interested to see whether rodents would actually use their affective communication for the good of another, for the benefit of another. And we know that rodents actually have what's called emotional contagion, meaning that they can catch another individual's affective state. So if one rat is frozen with fear, another individual rat viewing that frozen rat will also freeze with fear, even though there's nothing for that rat to be afraid of. So they're catching the affect of another. So what we were interested to see is whether they would use their information about another individual to actually go and help that individual.
So one of the things I really like about animal psychology as a topic is the different ways that researchers have to come up with to devise experiments and test their ideas. And it was really fun watching Peggy's talk in this respect.
Yeah, we have a rats in distress kind of situation.
Yeah, so here's Peggy talking about her experimental design.
So we set up a paradigm where a rat is put into a plexiglass tube that we call a restrainer, and it's not a restrainer is a little bit of a bad name because it's not terribly restraining. It's not a tight restraint, but nonetheless they can't get themselves out of it. The only way they can get out is if another rat from the outside opens the door and lets them out. And the question was, would another rat actually go to the trouble of helping this trapped rat and opening the door? Doesn't sound like a lot to do, but let me tell you that if we just put chocolate into the restrainer, it takes them 5 days on average to figure out how to open the door. And which is only basically on average 1 day quicker for chocolate than for the trapped rat. It's about the same. So it's a hard task for the rat. These are rats, and not only is it a hard task to figure out how to open the door, but also to go into the middle of this testing cage that we call an arena is also very stressful for the rat, because rats like to be at the edge of areas. They don't like to venture into the open areas because that's where they get eaten. So rats are very afraid of predation, and they tend to stick around the edges and the corners of an area. So what we saw was that the rats not only overcame their stress to go into the center of the arena, but they actually worked at it until they figured out how to open that door. Once they open the door, typically by accident, just because rats are not engineers and they cannot appreciate the fact that we put a counterweight there. So they don't really know that they should push that way because there's a counterweight. They don't really get that engineering thing. So typically they first open it by accident, but when the trap rat gets out, they have this good feeling, and it's reinforcing. And so the next day, they want to do it again. But the next day, they got a little bit more information. The business end of this restrainer, the place where the door is this end, so I don't have to worry about that end. So now they're going to do it a little bit faster. And after 2 to 4 days, they know exactly what they're doing. They go in, they go straight for the door, they lift it up and they open it. One of the ways in which we know that they know what they're doing, it was a very fun observation, which was that when they first open the door, it falls over and it makes this loud sound. Rats do not like unexpected events, so they freeze. When that loud sound happens, they freeze. But by the 3rd day of opening, they know that when they open the door with their snout, they know that there's going to be a sound. They don't freeze. They stop freezing because they know it's the expected outcome of a deliberate action. So we know that they know what they're doing. They're opening the door. And it's a very, very salient event. Once the trapped rat gets out, the trapped rat is very interested in exploring the arena because he hasn't been there. And the free rat is very interested in saying, hey, I'm very excited. I'm going to jump on you and lick you. And it's interesting that the free rat is more excited about the whole thing than the trapped rat.
Yeah, so I was fascinated at this point. So I actually stopped Peggy because it seems amazing that they engage in this behavior without actually being reinforced by the experimenters. There's actually no external reward that they're getting for doing this helping behavior.
Yeah, and we asked her to kind of clarify a little bit more about this internal reward and what exactly is motivating enough for the free rat to help the trapped rat.
A better way to put it is they're getting an internal reward that is reinforcing to the behavior. There's no external reward. And that was essentially the experiment. Would they do it for an internal reason or not? And the answer is yes, they will. We've taken the experiment in a few different ways. One is to further examine the motivation, and to do that we've tried to take the distress out of the trapped rat, out of the free rat, and those are experiments that that have been written up and should come out soon. And the other direction that we took it was to say, well, what's the relationship? What relationship do the two rats have to have in order for helping to occur? And at the time that we published our work, which was entirely, our initial report was entirely on cage mates, everyone said, well, they won't do it for strangers, because that was the obvious prediction. And so, yeah, I mean, we didn't know, but we decided that we would test. So we did test whether they do it for strangers, and the answer is yes. Rats will open and help strangers just as they help cage mates. And so what that led into was an entire study which demonstrates that what rats have to be, there's no parent role for individual familiarity in rat land. They don't need to know the individual that they're helping, but they do need to know the type that the individual is. So they need to know the type of rat that they're helping. And as long as they're familiar with that type of rat, they'll help any individual from that type. And that's a really exciting result. I think that what excites me about it from a human point of view is, and I have to preface this with saying that I am a mammal, and I believe that I am very close to a rodent, except I have a very fancy neocortex. But the rodent can do this task. The rodent is biologically mandated to help another in distress. And that suggests to me that I am also biologically mandated to help another in distress. And so what it tells me about the human condition and it is that we can learn something from biology when we talk about how can we all get along. That it's not just political science, and it's not just economics, and it's not just sociology or psychology. It's biology. Biology should have a seat at the table as to how we all get along with each other. And I can't think of a more important question that faces society today than how do we get along.
Now, towards the end of that segment, you heard Peggy talking about how individual familiarity with the trapped rat is not necessary for this emergence of the helping behavior. However, she mentioned that the type of rat is really important. Now, for her, what that means is actually related to the strain of the rat, which she's going to talk about in this next part of her experiment.
In her talk, Peggy mentioned that experience is biology, and here we're going to listen to just how that works in terms of cross-fostering studies.
We took rats on the day of their birth and we switched them into a litter from a different type of rat, so a different strain of rat. So we'd put albino rats into a litter from a Long Evans, which is a black-caped rat, a non-albino black-caped rat. And when they grow up, they help the foster strain, but they don't help their own strain, and that's a very telling experiment. But if you notice, they help the foster strain very late. Usually, our animals help they start opening the door around day 3 to 6, These guys didn't start opening the door till day 8 at the earliest. And so there might be a biology piece to that as well, that somehow the prenatal environment is enough to make them feel like there's something not quite right here, or there's some kind of a disconnect. We haven't done those experiments to test that, but that's an obvious guess as to what's going on. The animals that have been cross-fostered are very nervous. They're also significantly more nervous on, say, open field than animals that are not cross-fostered. But again, I think that they're cross-fostered postnatally, but it's not as though the prenatal environment is not an environment. So I would argue that the simplest explanation is simply that they learn something from that prenatal environment that is not in sync with the postnatal environment, and that's what makes the delay.
We'd like to thank Dr. Peggy Mason for joining us on the PrimateCast.
Yeah, it was really interesting. The last two speakers told us about these helping behaviors or pro-social behaviors in non-human animals, and now we're kind of going to continue along this theme, but instead of looking at direct helping behaviors, we're going to look instead at how animals might perceive interactions, either pro-social or antisocial interactions by humans. So now we're going to be joined by Dr. Jim Anderson of Kyoto University, and he's going to tell us about his work.
We were looking at the capuchin monkey's ability to evaluate humans based on the humans' interactions with third parties. And by that I mean interacting with another human as opposed to another monkey. And in one case, we looked at the monkey's evaluations of people who were either being helpful or unhelpful to the other individual who was trying to solve a task. And then later on, I looked at how the monkeys evaluated people who were exchanging objects between each other. And in some cases, the exchange was fully reciprocated, and in some cases, it was an unfair exchange. So somebody refused to exchange. And then we looked at how the monkeys felt about the individuals, and they could express that by accepting an offer of food given by the helpful individual or the unhelpful individual, or the reciprocator or the non-reciprocator.
So now we have Dr. Anderson telling us about how he goes about testing this.
The task itself, for the helper experiment, one actor, let's call her actor A, would try to open a container to remove a small toy inside. But she was struggling because the lid was closed tightly. So after 5 or 6 seconds of trying and failing to open the container, she would request help from actor B, who had been sitting beside her from the start. And on the days when actor B was helpful, on every trial, she would help actor A by co-manipulating the container and holding it stable to allow actor A to open the lid and then remove the toy. On days when actor B was unhelpful, when she received the request from actor A, on every trial she refused to help. She would simply briefly turn away to make a gesture, which means no, I'm not going to help, and then she would just look on while actor A continued to struggle with the task, and ultimately she failed on that task.
So it's pretty fascinating to think of these capuchins sitting there watching these human interactions, and at first glance you kind of wonder, well, you know, how is that something that's relevant to them, or how are they possibly going to pick up the nuances of this interaction? But here Dr. Anderson's going to tell us about that.
Okay, well, the capuchins watched while these interactions were going on, and then after the end of the demonstration, a screen would briefly come down to separate the two actors from the monkey, and then all of the equipment was taken away. Each actor would then offer a piece of identical food to the monkey. The screen was lifted, and the monkey was faced with the choice of taking a piece of food from one actor or the other. And what we found was that on days when the actor B was always helpful, the monkeys didn't discriminate between the two actors. They took food about 50% of the time from actor B and 50% of the time from the other actor. However, on days on which actor B had systematically refused to help, we found that the monkeys quite dramatically were less willing to accept food from the unhelpful actor. And this to us was surprising. And we continued by conducting some follow-up experiments which basically confirmed that the monkeys tended to avoid somebody who on that day was of an unhelpful disposition towards a fellow actor.
In Dr. Anderson's presentation, he talked about a second paradigm, looking at different activity levels of the helper and non-helper. Here he's going to tell us about the second condition, where the non-helper is actually occupied with something else.
We ran that condition for two reasons. First of all, we wanted the two actors' activity levels to be equivalent, because in our first experiment, the helper or the non-helper at first they were doing nothing. We equalised the activity level, and then we thought, well, let's see what happens if actor B doesn't help, not because of an explicit refusal, but simply because she's already occupied. So in that condition, when actor A failed to open her container and requested assistance from actor B, actor B didn't help, not because she refused, but almost because she didn't notice. Or maybe she didn't notice, but she was so focused on her own task that she gave no help. And what surprised us was in that condition, when both actors offered food to the monkey did not show a bias against the occupied non-helper. And that got us interested in wondering about whether the monkeys take intentionality of the act into account. Maybe the occupied non-helper wasn't intentionally refusing to help. Maybe she just didn't notice the help, or she was so occupied that the monkeys took that into account on the choice phase. So we think that this kind of approach that we came up with could actually be used as a way of getting at the monkey's understanding of intentionality during third-party interactions.
So it's often pretty common in these kind of animal psychological experiments to use human models, to model experiments and to have the animals respond to them. But it's also a little bit unnatural, if you think about it, to have the animals meant to be responding to humans. So we asked Dr. Anderson to talk about this issue and how it relates to his experiments.
First of all, we think that the result is even more impressive because the monkeys are observing an irrelevant to them interaction between two members of another species. And although it's true that the actors were caretakers, so the monkeys know them well, and we do think that the monkeys understand a lot about human behaviour because they interact with them every day. But there's always the question about whether using humans is the most appropriate approach for this kind of thing. In theory, it would be interesting to use conspecific models. I think it would be extremely difficult to come up with a paradigm. It's not impossible because people these days have cooperative paradigms between two monkeys. So we could, in theory, look at how using conspecific models would affect our kind of social evaluations. We haven't yet done it. It's probably something for the future.
Considering that the same people were being used for this experiment as human models, we were wondering if maybe the monkeys would bias their decisions on whether or not they took food from one person or another, depending on the role that they played on the previous day.
On the following day, the individual who may have been a non-helper that day may then become a helper because we counterbalanced the role. So on the following day, if the non-helper now became consistently helpful, we found that the monkey's previous bias would disappear. So this wasn't a bias against an individual that carried forward to the next day. It was a bias against that individual's general demeanour on that one day. But the monkeys didn't seem to hold a grudge onto the following day.
So we'd like to thank Dr. Jim Anderson very much for joining us on the podcast. It's always a pleasure to talk with him, and he's such an eloquent speaker, so I think all of the listeners will agree that you really come away from this interview with a great sense of what he did, how he did it, and what he found, and very visual as well. So thank you very much for that.
I would like to thank all of the other speakers that we had for this installment.
Yeah, and just as a reminder for everyone out there, if you want to find out more about what each of these researchers are doing, you can follow the links attached to the podcast webpage.
Stay tuned for the next episode in this series of installments from JSAP, where we hear about communication.
You have been listening to the PrimateCast, a podcast series dedicated to the study and conservation of primates around the world. Brought to you by the Centre for International Collaboration and Advanced Studies in Primatology of the Primate Research Institute of Kyoto University. Visit us online at www.cicsp.pri.kyoto-u.ac.jp/news/podcasts and follow us on Facebook at www.facebook.com/thePrimateCast and on Twitter at the PrimateCast.